Okay, so we're going to do our first example for strategy for series, and this is actually an old exam question. So the question is, does this series converge or diverge, and if it converges, compute its value. And the series kind of looks like a geometric series, but it's not quite a geometric series, and the trick here is to recognize that it's actually the sum of two geometric series, and we can break up this fraction to write it as the sum of two series for which we can calculate the value if they converge. So this sum, the sum from 0 to infinity of 3 plus 2 to the n over pi to the n plus 1, that's equal to the sum of what I get when I break up this fraction. That's 3 over pi to the n plus 1 plus 2 to the n over pi to the n plus 1. And now this is the sum of an plus bn, so I can break this up into the sum of two series, the sum from 0 to infinity of 3 over pi to the n plus 1 plus the sum from 0 to infinity of 2 to the n over pi to the n plus 1 by that additive rule that we got when we looked at the properties of series. Now I'm going to treat these two individually. They're both geometric series, and I'm going to write out a few terms here. So this one is equal to 3 over pi to the 0 plus 1, so that's 3 over pi, plus 3 over pi to the 1 plus 1, so that's 3 over pi squared, plus 3 over pi cubed, etc., etc., etc. Now this other one is equal to, the first term is 2 to the 0, which is 1, over pi to the 0 plus 1, so that's pi to the 1, plus 2 to the 1 over pi squared plus 2 squared over pi cubed, etc., etc. Now, remember, as a geometric series, this is a plus a times r plus a times r squared, and this one is some other a1 plus a1 times r1 plus a1 times r2, etc., etc. So, in order to use the formula, I'd like to identify the a and the r here. So the a is the first term, it's 3 over pi, and r is equal to the second term divided by the first. And that is equal to 3 over pi squared times pi over 3. Now I have a lot of cancellation there, and that's equal to 1 over pi. So the sum of this series is equal to a over 1 minus r, which is 3 over pi over 1 minus 1 over pi, which is equal to 3 over pi. This is pi over pi minus 1 over pi, so it's pi minus 1 over pi. And that's, of course, 3 over pi times pi over pi minus 1. And that's equal to 3 over pi minus 1. Now this second series, so that's my first part. Here I have to identify the a1, which is the first term, which is 1 over pi, and the r1 here is the second term divided by the first. And that is equal to 2 over pi squared times pi over 1 and that's equal to 2 over pi. And now I have the sum of this series, 2 to the n over pi to the n plus 1, is equal to a, which is 1 over pi, or a1, over 1 minus r1, over 1 minus 2 over pi. And that's equal to 1 over pi, over pi, which is 1, minus, so it's pi minus 2 over pi. And this is equal to 1 over pi times pi over pi minus 2. These pi's cancel, and it's 1 over pi minus 2. So I have the sum. The first series is 3 over pi minus 1. The second is 1 over pi minus 2. And now I have the sum of my original series, the sum from 0 to infinity, 3 plus 2 to the n over pi to the n plus 1 is equal to the sum from 0 to infinity, 3 over pi to the n plus 1, plus the sum from 0 to infinity, 2 to the n over pi to the n plus 1, which is equal to 3 over pi minus 1 plus 1 over pi minus 2. And because these are multiple choice, one should check that out in the answers, and we have our answer on this particular page is E.